Well, welcome students. Today we're going to be learning a little bit about photosynthesis, and we're going to start off with a discussion between two friends, Karen and Mike, and they're talking a little bit about how they differ in their opinions on how plants actually grow. And so Karen has this idea that plants are gaining most of their weight from materials that come from the air. And Mike, of course, disagrees and says, no. He thinks that plants actually are gaining most of their weight from materials that actually come from nutrients in the soil. And so they each take some turns in trying to support or provide evidence for their claims. And so Mike's the first one that goes ahead and he kind of talks to us a little bit about the fact that plants have roots that actually take up nutrients from the soil to allow them to grow. And he describes an experiment that would actually support his hypothesis. And he suggests that if you have a plant that's actually grown without fertilizer, that it actually grows up and it's about 50 grams in weight. Whereas if you grow a very, very similar plant and you actually grow it with fertilizer, then it can actually grow up to about 65 grams. And that's only from adding this 3 grams of fertilizer. And so he suggests then that plants are actually going to be gaining most of their weight from materials that came from nutrients in the soil. And this seems like maybe that's actually true because indeed we did increase the amount of plant biomass by almost 30% by just adding this little bit of extra fertilizer. But there are some potential flaws in his argument that he has. And a couple of these is, first and foremost, we can see that the increase in plant biomass by growing a plant with fertilizer was about 15 grams. But that excess of 15 grams, if we take away the 3 grams of fertilizer that was actually put into it to hopefully help it grow, kind of equates to this 12 grams that we can't really explain. We don't really understand where it came from. And if we're assuming that, according to Mike, the claim is that all this growth came from nutrients from the soil, then where in the world do these 12 grams actually come from? In addition, he's also kind of discounting the fact that you can actually grow plants without any fertilizer at all. I know that personally I have all these house plants in my house that I've been watering for years and years and kind of keep forgetting to give them fertilizer, but they still grow through time. And so this kind of is a bit of a weakness or a weak spot in his argument. So of course Karen kind of pipes in with some claims to support or some arguments to support her claim. And she suggests that you can actually grow a big plant in a little pot without very much soil at all. And she demonstrates this through an experiment that suggests that if you just start with a seed that only weighs about 1 gram and you put it on a pot with about 80 grams of soil and you wait for about a year, that you'll actually find that the soil has not really changed in mass. Maybe it even lost a little bit of mass, maybe just only about 2 grams. But the plant got huge. It's now 50 grams in size. And so she's kind of suggesting that we don't really add many nutrients, but it still gains a tremendous amount in terms of plant biomass. In addition, there is indeed this minimal loss, but she suggests perhaps it could just be explained by measurement error because it is really pretty small, or maybe there's some breakdown of some of that organic material that's actually in the soil that has nothing to do with plant growth. And so that overall, she suggests that plants gain most of their weight from materials that actually came from the air. But as we think a little bit about this, it's important for us to think about what's in the air. What is it that actually allowed it to grow? And so we can kind of break it down into kind of the constituent parts. And we know that about 80% of air on Earth is nitrogen gas, about 20% is oxygen gas, and then there's trace amounts of other gases, which includes many other things, including carbon dioxide or CO2. And so as we kind of think a little bit about those things and think about Karen's claim and even her experiment that she came up with, it's important for us to kind of identify that she also had some flaws in her arguments. First and foremost, if she suggests that it was air that was really contributing to most of the plant biomass, she kind of needed to isolate specifically which gas she was interested in. We can clearly see that there's many gases in the air, and so she kind of needed to concentrate on just one that she thought was important. In addition, it would have been beneficial if she had just focused on some fixed volume of air, but kind of exposing it to this open environment, you can't really control how much air is going in and how much is coming out or really be able to account for that. And so those are kind of some important pieces to consider. There were weaknesses actually in her actual argument. And so as we kind of think a little bit about how plants grow, we kind of take Karen and Mike's claims into consideration, we also have to kind of come upon this idea that there could be some other sources of mass contributing to make plants grow. Karen suggests that it's the air, Mike suggests that it's the soil, but if I ask a class of students, they often come up with several other ideas. One idea is sunlight, and I will kind of emphasize the fact that sunlight is energy, and energy can in some cases overlap with mass, but not always, and in this case it does not, as energy does not provide mass. Another source that students will often identify is oxygen, which of course we said is a component of the air, and that's actually not the component that Karen was actually interested in. And it's mostly carbon-based forms that are actually contributing to biomass, so oxygen is not one. But a lot of students also really kind of highlight water and saying, well, you know, we added water in all of these cases, and we're not really accounting for that. And so as we kind of think about water as a potential source of where these plants gain some of their biomass, we can kind of think back to one particular historic example, and that was Van Helmont, Jean-Baptiste Van Helmont in the mid-1600s conducted an experiment to kind of dispel this mystery of plant growth and understand where it really came from. And so here's an excerpt from one of the experiments that he did, and just to kind of give you a brief overview, he took a very, very large pot. He put about 200 pounds of soil in that pot, and then he put in this willow shoot, which he said only weighed about 5 pounds. And he let 5 years go by. He let this willow get bigger and bigger and bigger, which it did. It ended up, in the end, after 5 years, weighing about 169 pounds, just over. And he only was actually watering it as he went. He never put any other things in it. And he kind of found that at the very end of the experiment that the amount of soil was just under 200 pounds. And so his last statement kind of summarizes it, saying that about 164 pounds of wood, bark, and roots had arisen from water alone. But he also had some flaws in his experiment, because he suggests, or his hypothesis was, that water was the primary contributor to plant biomass. But in this particular case, he actually grew his plant in soil. And so he was actually adding this extra variable that would have been better if he'd isolated it and actually grown his plants in water to be able to see if that was the case. And we know that water does indeed help. If you have a plant and it grows without water, it will absolutely not grow. But the real question is, where does the biomass actually come from? And so we could actually do an experiment to test that and see if water is a major source of plant biomass. And so we could take those willow plants from Van Helmont's experiment. We could take the shoot that was at the very beginning of the experiment, and we could take the tree that was 5 years into the experiment, and we could actually take them and put them into this dryer, if they actually fit, and dry them out such that there was no water at all left in them, and it was just kind of the skeleton remains, if you will, not literally, but the remains of these willows, whether it was a shoot or a tree. And so if we were to do that and weigh them without any of that water, do we have an idea of which one of these would have been the case? Would it have been number one, where the shoot was actually weighing more than the tree without any water? Was it number two, where the shoot actually weighed less than the tree? Or was it that the shoot and the tree was exactly identical? And according to Van Helmont's experiment, he suggests, well, if you just add more water, like through 5 years, that it should have been that the willow was getting bigger and bigger just because it had more water. So if you get rid of them, that they should have been identical, as in selection number 3. But that's actually not what happens. What happens was what we see in example number 2, that if you dry them out, you get rid of all the water, you do end up finding that the tree does have more biomass than the shoot. Okay.